All right, so I've been getting a lot of questions about Riemann sums from our free response question that I gave you guys. So real quick, a quick overview. Here's our Riemann sum kind of formula, summation formula over the interval from A to B. All right, so what this is doing, it's actually taking your function, partitioning it into n rectangles. All right, so we're going to partition that into n rectangles. And then for part C, it's actually asking, as we take the limit as n approaches infinity, well, this is creating an infinite number of rectangles. If I look at my n here, from 1 to infinity, we're making an infinite number of rectangles for our function, all right? And then delta x would be the width of each of those rectangles, all right? So as we take that limit towards infinity, all that's doing is finding the exact answer, which is our integral, all right? So if we take a limit of a Riemann sum as n approaches infinity, that's just going to give us our exact answer, which is our integral. So let's look at this specific example. All right, from this problem, our function is f of x equals cosine square root of x over the interval from 1 to 3. All right, so I just copied our Riemann sum formula from above. All right, so we need to figure out what delta x is and f of x is. All right, the k is just some arbitrary x value is what we're telling us here. So let's do delta x first. So our little formula for delta x, you take your upper bound minus your lower bound, divide by the number of rectangles. All right, so our upper bound in this case was 3, lower bound 1, so we have 3 minus 1 over n, or 2 over n. All right, now we are also going to have n approach infinity in this problem, right? So as n approaches infinity, the width of each of these rectangles will be 0, right? 2 over infinity is going to be super close to 0. So the width of each rectangle is getting super close to 0, which is what we want to find our actual integral, right? All right, so now our x value. All right, so x of k, this is just your starting value plus delta x times some k value. All right, so for our example here, x of k will be equal to, what is our starting x value? Would be 1 plus, what was our delta x? We just did that right here. 2 over n times some k value. All right, so there is our xk. So we have to plug those two values into our Riemann sum right here. All right, so part C actually asked us to find this integral right here as a limit of a Riemann sum. All right, well, once the limit as n approaches infinity and from k equals 1 to n, all right, so we want some f of xk, right? Or in our case, our xk is right here. So 1 plus 2 over nk times delta x. Our delta x is 2 over n. All right, so if I simplify that and actually plug all of this into my function that I have up here, all right, so we still have a limit as n approaches infinity. Riemann sum from k equals 1 to n. My function was cosine square root. What's my x value? Well, it's the 1 plus 2n over k. Or sorry, 2 over nk. So let's see, cosine of 1 plus 2k over n times your delta x, 2 over n. and there's your answer. All right, so down here at the bottom real quick, determining, I guess, your K value and what we're going to on your summation. All right, if it's a right Riemann sum, you're gonna start with K equals 1, all right, because if you think about it, you're gonna start on the right side of that rectangle, all right, your K value of 1, right, up to n, up to your very last value if you're doing a right Riemann sum. But if you're doing a left Riemann sum, you'll start at 0, all right, but you'll start at the left side, and then you'll go all the way up to n minus 1, all right, thinking about like a RRAM and LRAM here. All right, we only go up to n minus 1 because we don't go all the way to a right with the LRAM. All right, and I'm going to go ahead and post another example and some practice problems from Khan Academy if you want to practice this a little bit more. All right, if we still have questions, I can try to answer a little bit more. Let me know.